with the analytics career on the rise in the recent times, and more people looking forward to building a career in it, we are here with an exciting session to help you get an expert's vision and experience as a guide to choosing this path. Today we have among us Mr. Karthik Shashidhar, the Senior Vice President and Head of Analytics, Business Intelligence and Data Science at Delivery, one of India's largest logistics companies. Formerly, he has worked with brands like IIM Bangalore, Hindustan Times, Crystal.ai, HT Mint, and Goldman Sachs. He has helped companies use data and quantitative methods to solve business problems. He is also an IIT Bombay and IIM Bangalore alumni. Please join me in welcoming Mr. Shashidhar, who will now be talking about 10 must know things for a career in analytics. Thank you for joining us. You can now start with the session, Mr. Shashidhar.
Yeah, okay, great. Thank you. I think I'll just keep it short. I'll probably talk for 10 or 15 minutes and I'll just take questions after that. I don't know what format you have for questions, but like you can just use that and I think there'll be a moderator who takes it and who will pass on the questions to me. I think that might work very well. Okay, so I'm Karthik. I head analytics and data science for Delivery. Been here for a bit more than 2 years. So I will, and I have had first up, I should mention that I had a bit of an unusual path into data science in that, like, I did not join any of the classic analytics data science companies. I did not go through the standard career path. For about 9 years, sometime in 2011, I was working for Goldman Sachs and I decided, okay, this analytics thing seems like some interesting thing. Let me do that. And I set myself up as an independent consultant in that. And then after that, I think it just that I happen to enjoy it and I happen to be good at it, and so I just stumbled into this profession in some sense. So which also means that the way I think about analytics and problem solving here is very different from how most other people in the industry think. So which means that whatever I tell you, please take with a lot of salt. Please if you were to listen to me perfectly, you'll do well in the interviews with me, but may not be doing well in the interviews with other companies. So I just want to say that, make that clear right up front. Anyway, so I think the way we do this is sorry, I just had some notes here on the side. So the way we do this, I just talk to you about some of the, I think I'll just keep it very simple. I'll talk about some of the work that my company does. I think it's the easiest way to introduce you to some of the kinds of problems that you can solve using analytics and data science. And before that, I think just to give an intro, I think data science is basically about how do you get, it's about, you might have heard of the scientific method. It's like when you have a problem, how do you solve it in terms of how do you solve the problem using there are a few steps and things like that where you identify the problem and you kind of try different things and see what works and formulate hypotheses, test hypotheses and things like that. That's the standard scientific method. Data science is basically the standard scientific method applied to using data, where we use a lot of the data that the company has and then or whatever, wherever you're working has, and then you try to generate insights out of it, right? So that's the very basic of data science. I mean, initially my plan was to use ChatGPT along with this session so that if I have any sort of, jargon related questions and stuff, I can just share my screen. But unfortunately, it seems to be massively overloaded today. So I don't have that luxury of using ChatGPT. But I think you should, whenever you get the chance, use ChatGPT. Any questions that you have, you should just ask it. And I think for all things like what is data science, what is analytics, what is the difference between data science and business intelligence and things like that, I think ChatGPT will do a much better job of answering than any human that you could talk to. So I think you should definitely do it. So in terms of broad careers, right? In terms of data science, if you were to talk about it, there are a few broad buckets, I will say. One is data engineering, which is in some sense a It sits somewhere between software engineering and data science. We'll talk about that. I'll just introduce everything and then we will go deeper into each thing. So one is data engineering. The other one is what I would call as classic analytics data science, which is like basically you have a business problem and you dig into the data to figure out why you have that problem and things like that. So that's the second one. Then there is machine learning, which is a small subset of data science, but which again like is pretty large. I mean, if you go on LinkedIn and look for data science, I mean, like most people will be talking about machine learning only. So that is basically like where you have a lot of sort of, let's say for example, put it simply, you have 100,000 images of dogs and 100,000 images of something else, and you feed that, you build an algorithm which just learns from this. You don't have to tell it, you need to look for this for a dog or something, and the algo will figure out what are the features that are associated with dog and not dog. And when you give it a new picture, it will when you give it a new picture, it will tell you whether it's a dog or not. So something of that sort. So that's machine learning. Then there is business intelligence. Business intelligence, I think, means very different things in different places. Again, the way my company sees business intelligence is very different from pretty much the rest of the world. In that, like, we look at business intelligence as answering business questions using intelligence from data. So I think that's how we look at it. But most of the world, it's more in terms of like how do you take the business information and present it to the management and employees and other people in an intelligent manner, in a way that they can understand what's happening. They'll get intelligence about the business through like sort of standardized dashboards and things like that. So we'll talk about that as well. And then so we'll cover data engineering, data science, analytics, machine learning, business intelligence, and then I think these are the very broad buckets. So I can sort of go slightly deeper into each of them and probably use some examples of problem statements that we solve in my company to be able to give you a good, better example of how we are, what all possible career opportunities lie here. So let's start with data engineering because I think it's a bedrock of all the data stuff. So for example, my company, I work for Delivery, India's largest logistics company. We move about anywhere between 1.5 to 2 million packages every single day. So we pick up 1.5 to 2 million packages every day and like deliver them, which means that like, and each package from the time it's picked up and till the time it's delivered gets scanned about 20 times on average. And what that means is that like we have about 30 to 40 million data points every single day. Now, when you're collecting so much data, how do you collect the data? How do you store the data? What kind of database should you store this in? If you can imagine our people all over India in, I think, some 5,000 different facilities all over India will keep scanning packages all the time. And each of these scans need to be sort of stored into a database with a whole bunch of details. I mean, we take some 1,000 different features of each scan in terms of like who did the scan, where it was scanned, what the nature of the scan was, and things like that. So how do you store this data? How do you store this data, and how do you sort of store it in a way that's easy for analysis later on? And again, how you store it depends on what kind of analysis you might want to do, but also you don't want to sort of over optimize when you're making your data storage decisions and stuff. So the data engineering team is responsible for making sure that all this data gets collected and stored in a nice manner, which can be later used for analysis and generating other kinds of insights and so on. And the skills that they broadly have is they need to know the understand data storage, understand data retrieval, how information is stored, what they given if you are looking at image data, what is the best way to store it in this particular context based on the analysis we want to do on that. If we are given the large number of the sort of data points that are coming every minute, how do you stream the data so that it goes and sits in some place? And you need to understand cloud technologies like AWS, Azure, Google Cloud, etc. So and understand different kinds of databases, what the trade-offs are, because some databases might be good for quick retrieval of old data. Some might be very painful for old data, but more recent data you might be able to get very easily and do more analysis with and so on. So it's a very what do you call it? It is about understanding a lot of concepts and then understanding the business and understanding the business needs and then setting up the setting up the pipelines and the structures and all that, so that you can the business can collect the data and then make use of it. And usually data engineering is usually part of the tech organizations in most companies. Okay. Next, I'll talk about which is my core competence, which is analytics. So analytics is basically it's in some sense about like one of my friends called it investigative work. So you will come up with somebody will come up with a business statement, or rather, like, for example, in my company, my team is responsible for coming up with the problem statements as well. Stuff like why is Flipkart not giving us as many packages as it used to? I mean, this is not a this statement is not true. I'm just taking a random example. Okay. So why is Flipkart not giving us as many packages as it used to? Now, I mean, there are some sort of intuitive ways to look at it. Maybe you can go talk to Flipkart and things like that. But if it's Flipkart, the big enough that you can go talk to them. But if it's a small seller who we are servicing, like, you don't have the luxury. I mean, it just takes too much time and it's not worth. So you just dig into the data. You look at where has the sales gone down. Let's say, for example, it could be on certain kinds of products. It could be on certain origins or certain destinations. And how do you sort of dig into the data? I mean, this is where I think what the skills that you need are like, I mean, one is, of course, like it helps to know a statistical package like Python or Julia or R or something. You need to be, I mean, fundamentally, you need to be fairly good at Excel for this. I mean, forget anything else. If you need to be good at Excel to be good at data. Again, that's my belief. You have a large number of data scientists who pretty much have never used Excel. That's a separate matter. But at least for this kind of analytics kind of work, it's good that and what you should do to get good at it is, like, there are lots of interesting data sets floating around. So, for example, if you go to Cricinfo, you'll get career averages and all the stats of every cricketer who has played in the last 120 years. And you can analyze that data, and then based on that, and then like try to find some insights. You can come up with like, why did I mean, I'm talking about cricket because that's something I like, but you could choose your own domain. So for example, you'll be like, does Sachin Tendulkar's century help or hurt India's chances of winning, for example, right? So that is I don't know. Yeah, you can look into the data, and then the different ways you can analyze it. So sometimes knowing statistical methods helps, but not always. You don't necessarily need to be too technical. I mean, being technical always helps, but what you need is curiosity. What you need is an understanding of the domain. So if you're working in logistics, you need to understand logistics. If you're working in cricket, you need to understand cricket, and so on. And the other thing is to be able to quickly slice and dice the data so that you can answer the questions that are being asked. Why have our service levels come down in the last 1 week? You need to know what service level is, like, how do you, what data you need to get to for service. I mean, this is extremely specific to my domain, so I don't expect any of you to get it, but I'm familiar with this, so I'm talking about this. But you need to understand the domain, you need to understand the data, you need to be an ability to connect one to the other, and you need a fundamental curiosity in terms of broad problem solving. That's pretty much what there is to the classic analytics kind of approach. Then there is there's a whole bunch of data science jobs. I think majority of the data science jobs that are floated nowadays are in machine learning. I gave a brief intro of that, which is like where you don't tell the algorithm. It's sort of like it's like writing algorithms, except that in machine learning, you don't tell the algorithm how it should solve the problem. You just give it a large number of examples of solved problems, and then like the machine will learn by itself in terms of how to solve it. So, for example, if you again, what I used earlier, you want to know whether a picture contains a dog. I mean, you can imagine small variations of this problem in different business contexts. So, for example, you can say that, does this picture contain a dog? Similarly, you can have, does this based on this X-ray, do you think you can see a broken bone? So it's sort of a similar kind of a example. So now what you do is, you don't tell the system that if there are two eyes and two ears and a wagging tail, it is a dog. You don't tell that to the system. what you do is to just give it, I don't know, a million pictures of dogs and a million pictures which don't have dogs, and both of the, and then the system will learn what are the features of dog and not dog, and then given a new image, it will tell you whether there's a dog in it. So what this sort of and it's a whole bunch of maths. I mean, the way the system, machine learning, you might sometimes when you see things like Chat GPT or something like that, it might be you might think it is it's some sort of magic, but it's not. It's all maths. It's just linear algebra. So at some, if you want to work in machine learning kind of stuff at a very deep level, I mean, obviously for all data related roles, it really helps to be good at maths, or at least it helps you to have a good interest in maths, whether you're good at it or not. If you, as long as you're interested in it, you will be able to figure things out and be able to solve the, attack the problems and so on. So yeah, so you, it's about, one was the, it helps to be good at maths, but even if you're not good at maths, I think like there are roles in machine learning where if you are able to understand all the packages that are, broadly understand how they solve the problems and what kind of problems are solved with what kind of methods, I think you should still be able to make a career in this. I think it's a very, very fast growing field. I mean, I know that there are a bunch of data scientists who have gotten laid off in the last 2 weeks in like Google and Microsoft and Swiggy and so on, but still like it's a fast growing field. So which means that there will be new opportunities for you in this one. So that is on, I was talking about all the machine learning kind of stuff. Then there is business intelligence. I will talk about it in the way that the industry understands it. It's about taking the data and presenting it in a nice manner. So you would have heard of technologies such as like there like some Tableau and Power BI, and Amazon has something and Google has something and so on. So every large software company comes up with its own sort of visualization tool. Here, the challenge is in terms of taking the data that's already there and showing it in a manner that can generate insights. So, for example, and this is more, it's a combination of an art and a science. So there is an engineering aspect of business intelligence, which is in terms of how do you, there is data sitting in a database, and the database is getting more and more data every minute. I mean, I think I told you about the roles of the data engineer and so on. And from after that, now that the data is sitting there, but you need to show insights to the business. How do you sort of engineer the pipelines, as we call it, in terms of taking the data from the database and then putting it up and showing it in a nice way? Like that's like just connecting those, making those connections so that you can show the data is one part of the part of the job, which is where you have the business intelligence engineers. Then there's the whole visualization aspect, which is in terms of like how do you represent this data? What is the way in which you can represent the data so that it tells the story in the nicest manner? So, for example, like if you are looking at, let's say, I don't know, like let's just take again Sachin Tendulkar's batting average over a period of time. Should you show it as a bar graph or a line graph? Should you smoothen the bar, smoothen it? If you were to smoothen the line, how much should you smoothen it by? And if how do you allow, if somebody, let's say, do you think people might be interested in comparing Sachin Tendulkar to Virat Kohli? So maybe we should give them a option for comparing two people on the same graph or something. And if you're comparing two people, because they would have played at different times, they would have played in different, like when Tendulkar played, 250 was a good score in ODIs. Now every match it goes to 350. So how do you compare Tendulkar and Kohli in that sense? So that kind of how do you show the data that exists, that there is a visual element of this, and bringing it all together in terms of the dashboards, like there is the engineering part, there is the visual part. There's also like some role in product management when it comes to BI kind of roles as well, and so on, right? And then there is the rest of, I mean, like it's very hard to classify. I mean, I've spoken about data engineering. I've spoken about analytics. I've spoken about classic machine learning. I've spoken about BI. There's also then there are some of these problems which it's hard to sort of pigeonhole them into any one domain or so on. So I just talk to you about 3 or 4 different problems that we in delivery solve. One is to figure out, for example, like, let's say you have ordered a package from Amazon. Amazon, it comes from their warehouse near Gurgaon and it has to come to you in Bangalore. So what is the best way to move that package? Like, should it go from, let's say, we have a daily truck that 2 or 3 trucks daily that go from Gurgaon to Bangalore. But should it go directly from Gurgaon to Bangalore, or would it be cheaper to send this package from Gurgaon to, let's say, Nagpur and then change the truck there and then to another truck to Bangalore? So how do you optimize our network so that we can get all your packages to your houses on time and still like keep our costs the lowest possible? So that's one kind of problem statements that we have here that we do in the data science team. Another is in terms of, let's say you're running a last mile delivery center in our company. So you have 1,000 packages to deliver and 20 people who are available to deliver. How do you figure out who should take out which package? There might be one person who is very familiar with, let's say, Indiranagar first stage, another who is very familiar with Indiranagar second stage. How do you make sure that all the first stage packages go to the first stage guy while not overwhelming him in terms of like you don't want to give him 200 packages because like he's not going to be able to deliver all of them in one day and so on. So these are that's another sort of problem that we solve it. Yet another is like we have a whole bunch of cases of fraud. You would have seen in the it'll come in the news once in a while, which is like basically you somebody ordered an iPhone and got a stone in place of it. So how do you figure out if it's a fraudulent order? Based on the details that you have of the order at the time that it got picked up, right? So these are some of the problems that we solve. These are some. It's hard to sort of pigeonhole them into either analytics or machine learning or data engineering or whatever. But all of them are things that we that are necessary for a business. So in terms of the skill sets broadly, I think again, pretty much for everything, you need to be curious. It helps to have a good interest in maths. I mean, I won't say you need to be good at maths, but you need to have an interest in maths. So if you don't want to do maths, you don't want to do this. Then if you need to have some sort of a feel for the business, though there are roles, especially in machine learning, where it's okay to sort of be more technical and not really sit close to the business. It's perfectly fine. And then there is and yeah, like I mean, just understanding how to sort of understanding data, understanding how you can sort of slice and dice something. How do you like just get good at the basic level, get good at Excel, and the second thing is just start. Data science is something which all you need to practice this is a computer and some curiosity. There are plenty of data sets available, so you should just start looking at some of them, looking at what you can do with it. There are sometimes some I don't know, like you can just for and once you do it for fun for a while, you'll know whether you're interested in it or not. If you're not, I mean, you won't do it for fun, so which means that you can choose another career. But if you are, then like you can all the work that you have done for fun, you can put it on GitHub and then like yeah, that should get you a job. So I think I'm done with what I wanted to talk about. So I'm happy to take questions if there are any.
Sure, Mr. Shashidhar, we do have some questions from the audience.
Yeah.
So the first one is, what qualifications and skills are required for a career in data analytics?
Nothing. 12th standard. I mean, I don't care about degrees. Again, what I'm telling you is I look at data science very different from the rest of the industry. So I don't care about degrees. Others might. Some people ask for PhDs and so on. But don't worry about your degree. I mean, as long as you're good at numbers, it's fine.
Great. Thank you, Mr. Shashidhar. So we have another question. What are the job opportunities available in data analytics?
I mean, every company, think about companies which go for slightly bigger companies. Don't go for, let's say, Series A startups and so on. So slightly bigger companies, because you need the company to have a certain amount of data to be able to sort of do data science there. I mean, that's a fundamental thing. Job opportunities available. I mean, you have a whole bunch of analyst roles, which is basically in terms of your job will be. Oh yeah, one skill I forgot to mention is like it helps to know how to get data. Like I was talking about data engineering and about how their job is to structure the data and put them in a nice manner so that like you can do analysis. For data science and analytics, it also helps to know how do you, how to sort of get data and how do you like writing SQL queries, for example, SQL, how do you get information which is stored in some weird place and all that you should know. Sorry, I missed the point of the question because I got distracted. What is it, Tanisha?
Yes. So the question was, what are the job opportunities available in data analytics?
Okay, job opportunity. Yeah. So one is, for example, like you have a whole bunch of analyst tools where your job is to extract data and build simple reports. So these are so the basic skills required for these, I would say, are at the basic level, it will be SQL and Excel. You should be good at both of them, and if you're good at both of them, you're already in the top 10% in terms of like the people who can do this job well. So that's one kind of opportunity. Then there is a slightly more deeper analytics kind of roles, which is like where you are given unstructured business problems and you need to find insights. Like for example, I told you, why is Flipkart giving us fewer packages this week? I mean, you should be able to solve that problem. You should be able to structure the problems and solve it. Figure out what data can be used to solve this problem, and then be able to get that data, dig into it, analyze the data, see pattern, find patterns. It's all about pattern matching if you think about it, and then maybe make some reports and dashboards and so on. So yet another in analytics again comes in analytics is in terms of just taking data, extracting data, and building reports out of it, or extracting data, building dashboards. So a lot of these are like sort of analyst kind of roles. Like we hire at pretty much all levels, from fairly entry level to, I mean, there's to like I'm a senior vice president doing exactly this day in and day out. So that's. I hope that answers.
Definitely, it does answer the question. We have more questions pouring in. So the next one is, what are the most in-demand tools and technologies used in data analytics?
I don't want to, I mean, just stick to open source tools. There's R, Python, Julia. Scala, I think, is used by some companies. So Excel is not open source. It's expensive, but it's super useful. SQL. So yeah. I don't want to. Yeah, don't. Yeah, stick to, apart from Excel, stick to open source tools. So.
Okay. Thank you, Mr. Shashidhar. Next question is, how can I gain practical experience in data analytics?
All you need is a computer. You can teach yourself, there are enough courses, and there is enough data available for you, and based on that, you can just based on you can make your own problem statements. You can play around with the data. It's quite and then like that will tell you whether you are good at it or not. If you are, then you can apply for a job. If not, you can find something else.
Great. We have another question that states, what is the career path for data analyst?
See, the industry itself is 10-15 years old, which means that there's no set career path. So it's pretty much the same thing. You join as a junior person, and like as when you do well, you become more senior. Like you start taking more complex problem statements. You start solving bigger problems for the business, and yeah, that's how it keeps going. And then like there will be like a aspect of people management which will come in at some point in time, and so on. So it's like any other industry, just that it's a very new industry. So I don't want to sort of tell you this is the career path, because it's hardly 10-15 years old. So.
All right. Thank you, Mr. Shashidhar, for this answer. The next question is, what are the most important concepts to know in order to excel in data analytics?
Excel.
Okay.
And, you need to have an interest in math. You need to have an interest in math and for numbers and so on. There's no such thing as concepts. It's just about curiosity. It's about curiosity. And see, the easiest thing to do is figure out something that you're interested in. Find some data sets in that. Do some analysis in that. You start with Excel and then move on to R or Python. Enough courses online. Stack Overflow is full of good answers for all of these. teach yourself, do some nice analysis, put it up online, somebody will find you and give you a job. So,
All right. For the next question we have, how do I start learning data analytics?
by doing it, by practicing with data. So by just like, so for example, take for example, like Sachin Tendulkar's scores in every single innings that he has played. What is his batting average? What is his strike rate? What is his batting average and strike rate in ODIs, T20s, and tests? Like that's how you get started. So you just take something that you are familiar with. I realize I've been talking about Tendulkar all this while, and most of these people may not be aware because I mean, like he retired 10 years back. But anyway, so.
Okay. Next we have, how does data analytics differ from data science?
According to me, there's no difference. But again, this is something you should ask ChatGPT. I think that will give you a better answer whenever you can log in. According to me, there's no difference.
Okay. And we have someone asking us, being from a non-IT background, can I learn data science or data analytics?
Absolutely, you can learn everything. I mean, there's no, as I told you, like there are jobs for everybody here. There are jobs for everyone depending on what you are interested in, what you are good at, and so on. If you're from an IT background and an engineer, yeah, you can be a data engineer, machine learning engineer. You can move into data science from there and so on. If you are from a non-technical background, as long as if you can understand the business, then you can get into the sort of the classic analytics kind of role, as long as you have some interest in maths. So I think that's a sort of broad. That little interest in maths is a sort of a broad necessary condition, but that apart, there's nothing really.
All right. Next question says, what are the languages that are needed to build a career in data analytics?
Nothing is needed. It's about your choice in terms of what you want to do. And also like you learn and don't learn languages, learn how to analyze data. And then after that, you can, whichever company you will join will tell you which language to learn and you can learn that language. But for your own analysis, you should use Excel, R, and Python are the three main things. You can start with Excel. I mean, you should definitely start with Excel. So.
All right. This one is a very interesting question. What are the common problems the data analyst encounters during analysis?
Okay, that's hard to answer because we pretty much every problem statement is our problem. So how can we grow our business is our problem. Why are our costs going so high is our problem. How can we make sure that more customers come and buy our product is our problem. Everything, I mean, why are so many people leaving us in the tech team? It's our problem. We can analyze pretty much any question that you can take. As long as you have some idea of the data that's available, you should be able to answer it using data. So every problem is an analytic substance. So.
For this question, would you also like to take up an example from your own experience where you got stuck into something while doing the analysis?
Oh, yeah, that kind of problem. I was thinking of problem statement that we solve. When you get stuck into something, I mean, yeah, sometimes for example, I remember where I get stuck in something is convincing people of the solutions. Saying that, okay, let's say, for example, you think that historically, for whatever reason, you would have thought that an average e-commerce package is 300 grams. Okay. Now, based on the recent data, the data tells us that it has gone to 600 grams. And you have used that in some model. Somebody else will come back and say that, why have you used 600 grams? Isn't it 300 grams? And then you have to sort of convince them, show them the data, show them that your analysis is fine and so on, so that you can tell them that you can convince them that what the data is showing is correct. I mean, so sometimes it's a lot of selling. I guess this largely at my level, but like it is a lot of selling in terms of like explaining what the model has told you to people who don't really understand the model, who don't trust the model, and so on.
All right. Thank you, Mr. Shashidhar. Next question is, what is a generally followed process for cleaning data before analyzing it?
there's no generally followed process. I mean, like if it looks clean to you, it is clean. I mean, you need to make sure that like, and actually, in some sense, I'll say that like don't formally try to clean the data. Start doing the analysis. If it gives you rubbish results, it means that your data is not clean, and then you better go back and clean it. And it'll tell you how to clean it as well. So, like if you have some data which tells you that Sachin Tendulkar's batting average is 2000, then you obviously you know that there's some mistakes somewhere, and then you can look into the data and you can find out where that mistake is, and then you can fix it there. So don't follow any of these sort of formal cleaning processes and stuff. Again, this might help you in your other interviews, not with me, but but yeah, in general as a practice, it's not well recommended. So
Great. So next question is, how do you present and explain technical concepts to a non-technical audience once data is analyzed?
I mean, the hard one. There's no, again, how do you explain? Like, see, you need to talk their language. You need to talk their language as much as possible. So you need to use the jargon that the non-technical people are using. So in some sense, one thing I found, again, this is also why I have stressed so much on Excel as part of this thing, is that like business people understand Excel. If you show them some complicated code in Python, I mean, they're not going to, it's just going to fly over their heads. They're not going to pay attention. But if you show them the data in Excel, that's something they are familiar with, which means that like it's easier for them to understand what you have done, and then they'll understand it. So I mean, it's not easy, but it's just about you have to make the effort to talk their language as much as possible.
Great. Can you name some of these statistical methodologies used by data analysts?
No, I can't, because I don't want to. I don't want to go there. I don't want to. You can Google it or ask ChatGPT, and you'll get the answer.
Okay, so that will be a task for the audience. Great. What are the types of hypothesis testing used today as per your understanding?
Whatever, hypothesis testing is a 50-year-old subject, at least to the best of my knowledge, and I don't think it has changed at all. So you can read any statistics textbook and it'll tell you what to do. I mean, like it's yeah. I don't want to see again. Like I think on a broader note, don't get too caught up in the detail in terms of what methods to use, what hypothesis testing methods to use, what languages to learn, and so on. I think largely this is more of a conceptual thing in terms of it's about getting a feel for what is there and so on. I mean, I'm talking about things that will make you good in your job, not good in your interviews, but like you just need to sort of understand where, you just need to get a feel for the thing and get a broad. If you know how to solve most problems, you can look up these things. So remember that, like in any job, you will have access to the internet, so you can. And Stack Overflow is pretty good, so you can ask your questions there. So.
Okay. Next one we have, how can one handle suspicious or missing data in a data set while performing analysis?
Yeah, again, we are going too much into the details here, but how do you handle the suspicious data? Yeah, one is to ignore it. Second is to, I don't know, fill it with some average. I mean, there's some standard techniques and you can Google it and find it out.
Great. Can you please elaborately explain what are the future trends in data analysis?
No, I don't know what the future trends are. So all that I can tell you is that like the amount of data that's being collected is going up. So I assume that the industry is going to continue to grow as fast as it has been. That's all I can tell you.
Okay. Can you please share your personal journey with us? We can learn a lot from your journey and trends on a similar path.
Okay. I don't think you should learn from my journey because it's a very unusual journey. I did my bachelor's in computer science. I did an MBA. I worked for a few years. Figured out that what I'm good at is in terms of looking at understanding patterns in data. I started looking for a job. I didn't. Back in 2011, there weren't too many people hiring for data science jobs. Data science wasn't even a popular concept at that point of time. So I became a freelance consultant. Started working with some fairly large companies, helping them solve their business problems using data. And I did that for a long time. Alongside, I taught for a little bit. I did some research. I was writing a column for Mint. I wrote a book, and all that happened. Then the pandemic happened, and I started getting bored. I stopped meeting people, which meant that I was just spending all my time doing consulting work. Then I was like, I might as well get a job, and I got a job at EduBridge. So that's pretty much my career journey. I don't know how repeatable it is, but yeah, the aspiration. So
Great to know that. So our audience wants to know that is the job role we will have, what is the job role that they will have after completing a course in business analytics? Is business analytics a better choice after completing CSE in BTech?
I am not a fan at all of courses and certifications. It's especially when it comes to analytics, data science and stuff. You just need to just do the stuff. Just do the stuff. So if you have a choice between doing a course and working somewhere, work somewhere. If you have a choice of doing a MOOC versus taking some data and analyzing it by yourself and putting it on GitHub or Kaggle or something, do the latter. So just do stuff. Don't bother about certifications and courses.
Great. So the audience wants to know who gets better salary, data scientist or data analyst?
It's up to your skill set. So like it depends on. I don't think this is again one of the sort of the new industry. So salaries are a random process. So it's hard to say.
Okay. There's another question. I want to understand the importance of R programming language in analytics, and if you can give a brief introduction of what all goes into learning it as a language.
I use it. I still use it every single day. I learned it in 2009, and I learned it that's over 14 years, which means that like I mean it's again difficult to explain how to use it. Well, I just use a lot of Stack Overflow and things like that. And yeah, it's another nice statistical tool which is easy to use. At least as far as I personally am concerned, I find it far more easy to use than Python. And if you come from a non-technical background, it's definitely a better tool than Python, because Python is definitely better if you come from a technical background, though it did work for me. And yeah, it's just an easy set of commands to analyze data, and you have nice packages for everything that you want to do. I mean, I don't know if there's anything else I should say about this.
We have another member from the audience who has a very specific question. So the member says, as a supply chain management graduate and being from a non-tech background, what are the digital skill sets required to make a career in logistics and SCM companies? You being the VP of India's largest logistics company, what do you suggest for us to work on to make a good career growth in this domain?
If you're an SCM person, if you have already done a degree in SCM, I mean, I'm sure like we are expanding some of our facilities and we are hiring somewhere. So just look out for our job postings and get a job and start working. That's all. So I think it's a very simple thing. I mean, study versus work. Do projects versus study, do projects and things like that. So that's so yeah. I mean, if you have already done a degree in STM, just get yourself a job and then like yeah.
Great. We have another question. Which one is better, Python or Pandas for data analytics?
Pandas. So, and Pandas is a package in Python, by the way. And for data analysis, please use Pandas. Don't use Python without Pandas. It just becomes impossible to do. So.
Okay. How to deal with new algorithms in data analysis?
Learn them. That's all.
Okay. So there's another question about the packages that an analyst can get as a fresher. Also, if we have experience in other fields.
Don't use SAS. It's paid unless you work for IBM. I think unless you work for SAS, not IBM, or some research lab, you're not going to have access to it. So it's not worth it. There's enough open source tools like R or Python or Julia, which you should learn. What is the other thing mentioned?
Yes. So as a fresher, and even if a person is experienced in other fields, then what will be the packages like?
No, what are they talking about salary packages? That's the case. I have no clue. But like, I only know the salary packages for the roles that I am hiring for. So, but yeah, I don't know. I think you'll have a bunch of career counselors here. So I think we should get one of them to answer this once I drop off.
Okay. Next question is, what is the accuracy of the data we are analyzing? How do we know whether the data analyzed is correct or not?
That's an interesting and important question because, I grew up in the 90s. I had this thing in computer science then we said garbage in, garbage out. So if you're analyzing bad data, you are going to get rubbish analysis. So how do you know if the data is good or bad? Sometimes, you should look at the data. You should just look at the data. You should just see if something's standard. Like for example, if there's a column which has people's height, just make sure that if it's in inches, it's somewhere in double digits. Otherwise, it doesn't make sense, right? Sometimes just analyze the eyeballing the data makes sense. Sometimes just make some simple graphs and plots with the data, and that will tell you whether it is if something is wrong or not. Otherwise, you just go ahead and do the analysis, and then the analysis will throw up rubbish results, and that will tell you that there's something wrong with the data somewhere. It's more likely that the data is wrong than your analysis is wrong, and then you can go back and point you into how to change the data, how to clean the data, and so on. So.
Great. Our audience also wants to know what data analytics self-study material sites or channels can you suggest for learning?
Nothing. Stack Overflow.
Okay. And they also want to know, personally, what books do you read to keep yourself updated with latest trends?
What books do I read? I don't read books for latest trends because books usually take 2-3 years to publish, which means that none of the books will have any latest trends. Just hang out on Twitter, read a whole bunch of blogs, things like that. And that's there are a whole bunch of tech newsletters. Nothing immediately comes to mind, but as long as you're following them and following the right people on Twitter, I think it's will be fine.
Thank you. Next one says, can you describe a situation where you had to present complex data analysis to a non-technical audience, and how did you approach it?
Okay. This is my everyday job, if you think about it, presenting complex data analysis to a non-technical audience, because though again, I guess in my company, the people I talk to are largely somewhat technical, at least they'll, so how do you present? See, I'll tell you some of the things. One is to make good visualizations. That's an underappreciated part of data analysis in terms of how do you show the data. So sometimes, for example, maybe, I don't know, there are, maybe you will, let's say, for example, you want to show that Sachin Tendulkar is the greatest batsman of all time. You take everybody who played around the time when he played maybe minimum of 20 test matches, look for average and strike rate and plot some kind of a scatter plot, and then you'll see where Tendulkar is and you color him differently. So that somebody who sees, it's basically about, it's all about manipulation. It's a data analysis is all about telling lies. It's about telling the message that you want to tell using the data that you have, which means that you go in prepared with material that shows what you want to show. So things for example, a scatter plot of averages versus strike rates for everyone, which Sachin Tendulkar shown in bold, and then you can, when they look at the map, they know that he stands out. But is average and strike rate the right thing to do, or to look at average and something else, and or should you just look at one variable? I don't know about that. That's all the prep you need to do before the meeting. But as long as you have done the prep and you know how to communicate the work, if you can figure out some nice visual way to communicate what you found, that's great. It will work for a non-technical audience. Also, what works for a non-technical audience is sometimes just showing some kind of data tables and things like that. Again, follow the good sort of visualization practices, and you should be fine.
Great. So somebody from the audience is asking, I am learning data science from 5 months, and the important things that I've noticed is asking the right questions and then getting the data. What can be done for improving the skills of asking the right questions?
Work on more problems. Basically, you're absolutely right. That is the key part of data analytics, which is asking the right questions. And the only way you can become better at it is by doing more of it. So there are some stuff you would have done in your course. Also, do some of these things elsewhere. Like, I mean, with some random data that you find and things like that, ask questions and find the data. Like, I mean, it only comes with practice. I don't think there's any other, you can't find this in a book. So,
Okay. And what kind of questions are asked during an interview for a data analyst? How does one prepare for it?
what kind of questions are asked for data analyst? I mean, you will definitely expect questions on how do you extract data. That's knowing SQL. That's one thing that's definitely going to be asked. They will probably give you a data set and ask you to analyze it, which means that you should have practiced some Excel and things like that. So then there will be they'll ask questions on what else do they ask? Data analytics. See, it's basically, if you think about it, it's about extracting data, analyzing data, presenting data. So that's what they'll ask you. If you run into somebody like me, I'll ask you some fairly high-level maths questions. But otherwise, yeah, like it's about logic, about whether you can think. They'll ask you some puzzles and standard kind of hiring stuff, but also in terms of how do you extract data, process data, and present data. That's about it.
All right. Thank you, Mr. Shashidhar, for that answer. The next question is, you would have built a team, and assuming that you hire many people so far, can you share some points on what do you see in a candidate while selecting them for a position of data analyst?
Fundamentally, it's somebody who's curious, somebody who has shown that they have an interest in this. So, for example, I interview a lot of people who I'll be like, what? Give me some example of data analysis that you've done outside of your job. They would have done nothing, which for me, it's like, okay, they're probably just doing their jobs. I don't know if they really have an interest in this also or not. That's one thing. The other thing is in terms of yeah, there need to be. I look for people who can think logically, who are good at. I test for basic maths and statistics and so on. I mean, that's something that I definitely test for. I test for given us data set. Sometimes I give them a data set and ask them to analyze it in front of me and present some of the insights. Sometimes that can be as part of a take-home assignment as well. So it is about what do you say, analyzing data. It's about presenting data. It's about extracting data. The extracting data, I don't ask somebody from my team will easily ask, but yeah, that's how I have. It's about data and logic and maths and things like that. And also, like, yeah, one other important question I always ask: give them a business problem and ask them how they are going to model it as a data analytics problem. Because I think, as somebody asked 5 minutes back, like the biggest part here is in terms of how do you ask the right questions, and so you need to test whether they're able to ask the right questions. Otherwise, you'll end up doing 90% of their work. So,
great. Next question is, what are the important responsibilities of a data analyst?
Like identifying problem statements when there is a problem in the company somewhere, because you are always looking at the data, you should be able to flag it and say that there is a problem when there's a problem, and then like you thinking up of solutions to the problems that you have identified, and then like you're generating insights, presenting them to the business, maybe building some algorithms, putting them into the product. All of them are responsibilities of a data analyst.
Okay. Next is, what is clustering? Can you please name the properties of clustering algorithm?
No, it's too technical. I'm not handling this today.
Okay. Again, we have another question. What is the difference between the true positive rate and recall?
Again, a technical question I'm not answering.
Okay. What do you do for data preparation before you start a project?
There's no standard process. I think I've taken this question before in terms of like, you just eyeball the data, look at the data, you'll know if something stands out, if something is wrong, and so on. And then you sort of deal with that. And then start your analysis. Once if your analysis is rubbish, you'll know that like there's some data that you have a problem with.
Okay. Also, the audience wants you to talk about the data visualization in a little depth.
See, it's basically about taking the data that's there and presenting it in a way that people can understand easily. So if you think about it, what you need to remember is that you are in control of the message. So you need to, so let's say you want to present the message that the sales have gone up significantly. Now there is a way you can, again, it comes with practice. You can draw a graph of the sales in a way that it shows that like it has actually gone up significantly. I mean, so it just comes with practice. It's about the stories you want to tell. I remember that the stories that you as the analyst wants to tell. It's not like, so there's no story that you have to kind of retrofit to and so on. And yeah, so that's about it. Like, I mean, you need to know what story to tell. First of all, you need to know what story the data tells you. I mean, that there can be multiple versions of that, and which of them you want to tell your audience. And then once that is done, you just with some practice, you'll start with some visualizations, and you will find out at some point of time that people are interpreting the wrong things from it, and then you'll figure out that there should be a different set of stories that you should have told, and so on. So yeah, that's how you do it.
Great. Thank you, Mr. Shashidhar. So that was the last question we had from the audience. This was a very educational session, and rest of the questions we will be sharing it to you on email if you could answer as many as possible.
Sure, I'll try to, but I think I've answered a lot of them now, but I'll try to answer
Definitely.
any other. Okay, thank you. Thanks all of you.
Thank you once again, Mr. Shashidhar. You can exit the webinar. You have a great day.
Thank you. Bye.